Objective number 4. Use combinations of rules. Note: power rules. A to the mth power raised to the nth power equals a to the m times n power. In other words, we have a power that needs to be raised to a power. We can accomplish that by taking the base and multiplying the exponents. Part B. AB to the mth power equals a to the nth power times b to the mth power. Therefore, what this is basically saying, if we have a product that's to be raised to a certain power, we can obtain that by taking each individual factor and raising it to that particular power. So AB to the nth power equals a to the mth power times b to the mth power. Part C. The fraction a over b raised to the nth power equals to a to the nth power over b to the nth power, where b does not equal to 0. Notice here, both the numerator and the denominator have to be raised to the nth power. Also, a to the minus m power over b to the minus n power equals to b to the nth power over a to the nth power, where a and b do not equal to 0. Notice what this is basically saying is, if we have a negative exponent in the numerator and a negative exponent in the denominator, we can switch the bases. That is, the a to the minus m power becomes the denominator when we rewrite it to the positive m power. B to the minus n power, which is the denominator, becomes the new numerator, but is raised to the positive n power. This allows us that flexibility. Then finally, a over b to the minus m power is equal to b over a to the positive m power. We've actually already implemented that rule. Example 1. Simplify each expression. Assume that all variables represent non-zero real numbers. Part A. 5 to the 4th power raised to the 2nd power divided by 5 to the 3rd power. Well, 5 to the 4th power raised to the 2nd power becomes 5 to the 8th power, because we have a power being raised to a power. So it's 5 to the 4 times 2, which is 5 to the 8th power, divided by 5 to the 3rd power. Now, we have two powers that have the same base and its division, so we can subtract the exponents. So 5 to the 8th power divided by 5 to the 3rd power becomes 5 to the 8 minus 3 power, which is 5 to the 5th power. And of course, 5 to the 5th power means 5 times 5 times 5 times 5 times 5, and which becomes 3,125. B. 2x to the 2nd power times 2x to the 5th power. Well, in this case, we have two powers that have the same base being multiplied. So we should be able to keep the base, add the exponents. Therefore, this becomes 2x to the 2 plus 5 power, which is 2x to the 7th power, which is 2 to the 7th power times x to the 7th power. 2 to the 7th power becomes 128. X to the 7th power becomes x to the 7th. So final answer, 128 x to the 7th power. Part C. 4x to the minus 1 power divided by 3x squared to the minus 2 power. Once again, we can invert these positions and change the sign of the exponent. So the new expression becomes 3x squared to the positive 2 power over 4x to the positive 1 power. Simplifying that by raising 3 to the 2nd power giving us 9, x to the 2nd power giving us x to the 4th, over 4x to the 1st power, which is just 4x. But we can simplify 9x to the 4th over 4x and getting 9x to the 3rd power over 4, or 9 over 4 times x to the 3rd power. D. 2x to the minus 3 power over 3 to the minus 1 power, y to the 4th, all raised to the minus 4 power. Once again, the shortest way is to rewrite the numerator so that we can bring the 3 to the minus 1 power to the numerator, so it becomes 3 to the first power, or 3. Similarly, x to the minus 3 power that's in the numerator can be brought to the denominator so that it has a positive exponent, and thus we'll obtain 2 times 3 over x to the 3rd power, y to the 4th power, raised to the minus 4 power. Okay. At this stage then, since we have a negative exponent, minus 4, we can now invert the fraction that's inside parentheses, putting the 6 in the denominator and the x cubed y to the 4th in the numerator, and then changing the sign for the exponent to a positive exponent, and that will allow us to quickly get to the answer by raising each of the factors inside parentheses to the 4th power. So x cubed raised to the 4th power gives us x to the 12th power, y to the 4th raised to the 4th power gives us y to the 16th power, and the denominator 6 raised to the 4th power give us 1296. Then to part E, we have the quantity x plus y to the minus 9 power divided by x plus y to the minus 10 power. Here we have two powers that have the same base that are being divided. So what we can do is retain the base and subtract the exponents. So this can be written as x plus y to the minus 9 plus 10 power, which becomes x plus y to the first power, which is x plus y. Then to F, we have x to the minus 4 power times x to the 6th power times x to the minus 3 power. In this case, we have powers being multiplied. We're multiplying powers that have the same base. So we keep the base, which is x, and simply add the exponents. Therefore, this becomes x to the minus 4 power plus 6 power minus 3 power, which gives us x to the minus 1 power, which by definition is 1 over x. And finally to G. Here we have m to the minus 4 power times q divided by n to the minus 3 power, all raised to the minus 3 power. First, what we can do is we can take this expression and simplify the expressions inside so there are no negative exponents. That means we can take this m to the minus 4 power, which is in the numerator, to the denominator, and it becomes m to the positive 4 power. The n to the minus 3 power in the denominator can be taken to the numerator position, and then the exponent changed to positive 3 power. So now the new expression is n cubed q divided by m to the 4th power raised to the minus 3 power. Now, what we can do to simplify this very quickly is once again invert the fraction in parentheses so that it becomes m to the 4th power over n cubed q raised to the positive 3 power. And now all we have to do is expand this and get our final answer. What that means is we take m to the 4th power, raising it to the 3rd power by multiplying the exponents, give us m to the 12th power in the numerator. The denominator, we take each one of those factors, raise it to the 3rd power, giving us n to the 9th power, q to the 3rd power. So our final answer is m to the 12th over n to the 9th times q to the 3rd. God